When we build antennas, this is what we typically strive for. We either use copper wire or pipe, such as this, for shorter antennas, because copper has about the best conductivity for the price. The only problem with copper is that it's dense. It's heavy. So you can only build an antenna so big with it before it collapses under its own weight. So then what we tend to do is we go down one grade to aluminum. It's lightweight, it's fabulously lightweight. However, it's still not as strong as something like steel, and so it has a tendency to bend, but it is lighter. It's much lighter. And the other problem with it is the conductivity isn't quite as high as copper, so you're losing a little bit of efficiency with it, and it is noticeable, I guess, at higher powers maybe, or I don't know. Typically you don't notice it though. It's a measurable effect though, is what I'm trying to say. So you're always making these compromises and stuff, but really, so I got to thinking about this problem. And what do you typically think of when you think of current running along your antenna wire, right? Well, there's something called the skin effect. So what this means is that the current has a tendency to only flow on the surface. So guess what? Even something as thin as, say, this, only the very, very outside, and it gets worse at higher frequencies, only a tiny, almost like micron thick layer on the outside is actually conducting. This isn't so much a problem down at, say, HF frequencies, but at VHF and UHF, you start to notice it probably on maybe 20-meter band, but it's measurable even on bands above 1 megahertz, So everywhere above 1 megahertz, your antenna is really only this tiny thin layer on the surface. So this is what I came up with. This is my idea. Why don't we use, since we're just wasting all this material, why don't we just use a conductive material that's thin anyway? We can save on weight, and then bond it to a core material that's inherently light and strong. This is fiberglass. You could do this with carbon fiber. There's, since carbon fiber is conductive, there's a few things about carbon fiber that you would have to take into consideration. But what I did was I took some copper tape, some foil tape, and I applied it to this length of a fiberglass tubing, and actually it turns out this is probably overkill. I didn't need it to be this thick walled tubing, but it works. It's still a lot better than this, and it's even actually better than the aluminum, and it allows you to do other things as well, such as this. Now in the middle here is my feed point, and you just take your coaxial cable and you connect it there, and I use a couple of hose clamps. I was using a couple for testing. It holds up well as long as you don't over tighten it, and you have a continuous length of material as your dipole without the problem of support in the center and insulation and all that other stuff. It just takes care of itself. And so at the other end, I've got another hose clamp, and I've got a couple of wraps of duct tape to tighten up the fit into the tubing. And this is a vertical, so this sits out in the tubing, and then see this here, this hose clamp keeps it from slipping down into the tubing, and that works pretty well. I was testing it like that, and there really isn't any difference between this and using pipe like this. The other problem you run into, you could use wire, and oftentimes we use wire to get around this problem of weights, and the weight of copper. And the problem with that is the wire is very thin. So what you have is your bandwidth suffers. You're forced to tune the antenna to either the low or the high end of the band, because the antenna won't cover the whole band, and this is a problem that arises because of the diameter of your aerial. The thicker the conductor, the wider the bandwidth you get out of it. And with this like this, you have no problem. You basically have no problem with diameter. You can make the diameter whatever you want, whatever you can get, whatever you can source for a core material is your diameter. So that was my little brainstorm I came up with a couple years ago. There it is. And so don't forget to rate, comment, and subscribe and stuff, and I'll see you in the next video. Thanks for watching.